is going to be collision problem, elastic collision problem. So you're going to prove that collision before is equal to collision after. That means the kinetic energy conserved. This is what we're going to try to prove. So now the problem is a proton, that mass of proton is 1.01 u, and 1 u is equal to 1.67 times 10 raised to negative 27 kilogram, and velocity of proton is, let's say, 3.6 times 10 raised to 4 meter per second. All right, so this proton strikes a helium. It strikes a helium whose mass is 4u and whose velocity is 0. So that helium is at rest. This is before. So what happened after? After the collision, the proton and then the helium moves this direction and proton moves this direction with velocities. You should use prime to make sure that this is after the collision. Okay, so we have, our goal is to find b prime of p and b prime of h. So how can we find it? So this is our step number 1. So let's do step number 2. Step number 2, what we're going to do is we're going to write momentum before is equal to momentum after, because momentum is conserved. I hope you understand the conservation of momentum. So m1 v1 plus m2 v2 is equal to m1 v1 prime plus m2 v2 prime. So I'm going to bring all the m1 v1 to the left side and send all the m2 v2 to the right side. So m1 v1 minus m1 v1 prime is equal to m2 v2 prime minus m2 v2. All right, so what can we do now? We can factor out m1. So v1 minus v1 prime is equal to m2 v2 prime minus v2. All right, now this looks good, so we're going to call it equation number 1. We're going to call it equation number 1. Now we're going to do the second part step number 3. We're going to do kinetic energy before is equal to kinetic energy after. So what does that mean? Kinetic energy before, kinetic energy after. All right, so m1 v1 square plus half m2 v2 square is equal to half m1 v1 prime square plus half m2 v2 prime square. All right, now all the half are cancelled. So half cancel. So you're left with m1 v1 squared plus m2 v2 squared is equal to m1 v1 prime squared plus m2 v2 prime squared. Now what are you going to do with this? You're going to bring all the m1 v1 to the left side and send all the m2 v2 to the right side. So m1 v1 is squared minus m1 v1 prime squared is equal to m2 v2 prime squared minus m2 v2 squared. Now what you can do, you can factor out whatever you can factor out. On the left side you can factor out m1, on the right side you can factor out m2. So let's do that. Now you see that something beautiful is standing out, and that is the difference of 2 perfect squared. All right, so let's do that. Alright, so this looks good. Now we're going to call it equation number 2. So I have equation number 1 and I have equation number 2. Now we're going to do step number 4. So step number 4, what I'm going to do, I'm going to divide equation 2 by equation 1. Equation 2 by equation 1. So what is our equation 2? So I'm going to copy and paste. Let's see whether I can copy equation 2. It would be great if I can copy it. So modern technology allows us to do lots of things, lots of good things. Voila, I was able to copy it. So now equation 2 divided by equation 1 as I promised. So let's see whether I can copy equation 1. It would be nice if I can copy equation number 1. Alright, so let's see whether I can put equation number 1 on the bottom of equation number 2. This is beautiful. This is beautiful. Now I have to divide it. As I said, I am going to divide it. So let's use the yellow to divide. So I'm going to divide it. And let's use the red to cancel it. So what can we cancel? M1 cancel, V1 minus V1 prime, B1 minus B1 prime cancel, M2 cancel, V2 prime minus V2 cancel. So what are you left with? So what are you left with? You left with V1 plus V1 prime is equal to V2 prime plus V2. Okay, that's beautiful. But earlier you started with proton and helium. So now it's time to replace proton and helium accordingly. So you're going to call V1 is V proton and V2 is V helium. See, this is why we use the variable 1 and 2 just to be replaced at the right time, at the right moment. Now it is the right time and it is the right moment. Okay, good. So before I do that, I'm going to write before, and before is equal to after. So before, this is before. Why this is before? Notice this one is before. Before what? Before the collision. Alright. So and this one is after the collision. This one is after the collision. So I'm gonna bring the before one, the one without the hat, to the left side, and I'm gonna bring the other two to the right side. Now it's time to change the variable. So V1 means VP minus VH is equal to VH minus BP prime. Okay, good. Now you see this one goes to 0. Why this one goes to 0? Because the helium is at rest. Helium is at rest. Good. So that means BP is equal to B prime H minus B prime P. Now this is the most important equation so far. Okay. Now what do we have to do? We have to isolate. First we can isolate this one, and then we can isolate this one. Okay, let's do it. Alright, so let's do it. So VP plus B prime P is equal to B prime H. Alright, so this is one of the equation. Why? Because we want to find B prime H. We want to find B prime H. Who told you? I told you. We want to find B prime H. Good. Now we're going to isolate the other one. Alright, so this is B prime H. So we have B prime H is equal to BP plus B prime P. Good. Now we have to have the other one, B prime P. So let's bring BP plus B prime P is equal to B prime H. So B prime P is equal to B prime H minus BP. So B prime P is equal to B prime H minus BP. All right. Why do we have to do the B prime P? Because look at here, B prime P. All right. So we are almost there to prove that in elastic collision, kinetic energy is conserved. So that was our hypothesis. What was our hypothesis? Our hypothesis is in elastic collision, kinetic energy is conserved. All right. So we are trying to prove this hypothesis, and we are almost there. So now we're gonna I'm gonna copy and paste these two beautiful equations over here. All right, over here. Now I'm gonna move over here because this is where we started. All right, this is where we started. Okay, good. So I have these two beautiful equations over here. Okay, good. Now I'm gonna start with two arguments, of course. M1, not M1, sorry, is we're done with the variable, so it's now the time to use MP VP plus MHVH is equal to MP BP prime plus MHVH prime. This one go to 0 because this one is at rest. Because this one is at rest. Therefore this one go to 0. So MP BP is equal to, now as you said, B prime P, and we have a candidate for B prime P, and B prime P is this one. So you're going to replace that by that. So B prime H minus BP plus now it's time to distribute. Okay, so we're going to distribute it now. MP VP is equal to MP V prime H minus MP BP plus MH BH prime. So what are you going to do now? We're going to, as you see that this one and this one, they are the same. So you're going to bring to the left side. So MP BP plus MP BP is equal to, you also see that, you also notice that B prime H and B prime H is the common factor. So B prime H MP plus MH. Voila. So now finally you find V prime H, and that 2, because MP BP, so 2 MP VP over MP plus MH. So now what are you going to get? 2 times MP is 1.01. BP is 3.6 times 10 raised to 4. Divide by 1.01 plus 4. So if you calculate it, it's going to give you, let me see, two times 1.01 times 3.6 divided by 5.01, 1.45. So 1.45 times 10 raised to 4, and that would be meter per second. So we found this one just so far. So far we found V1 prime. So V1 prime, now we found V prime H. V prime H, we found V prime H. So B prime H, that means the helium after the collision moves 2.45 times 10 raised to 2.45, 1.45 times 10 raised to 4. 1.45 times 10 raised to 4 meter per second. Now we have to find, we just found this one. Now we have to find this one. Now finding this one is not that difficult. So now we're gonna M1 MP VP plus MH VH is equal to MP VP prime plus MH VH prime, right? So this one is 0 is because the helium is 0 before the collision. So MP BP is equal to, now as you see that I'm going to replace the last time I replaced with V1 B prime H. So V prime H last time I replaced it, so MP plus MH. No, B prime H, so B prime H. So last time, okay, so B prime H, no, B prime P. So I did V prime P. Now I'm going to do B prime H. So B prime H is this one. So MP B prime P plus MH. B prime H is this one. BP plus B prime P. Okay, now good. So I'm going to distribute this one. MP BP is equal to MP V prime P plus MH VP plus MH B prime P. Okay, now as you see that what I have to find, my goal is to find V prime P. So B prime P. So my goal is to find B prime P. So B prime P. So I'm going to bring this one over here. So MP BP minus MH VP is equal to V prime P. I have MP plus MH. So V prime P is equal to MP plus MH and MP VP minus MH VP. Alright, so MP is how much? Alright, it's easy. MP is of course 1.01. VP is 3.6 times 10 raised to 4 minus MH 4. VP is 3.6 times 10 raised to 4. Okay. Alright, so 1.01 plus 4. So now let's see what we're gonna get. So 1.01 times 3.6 times 1.01 times 3.6, and that would be 3.636 minus times 10 raised to 4 minus 4 times 3.6, 14.4 times 10 raised to 4. So it's probably gonna be negative velocity. So 3.636 minus 14.4 is equal to negative 10. So negative 10 divided by 5.01, so is 2.14. So negative 2.14 times 10 raised to 4 meter per second. So negative 2.14. So this one is negative. This one is negative 2. What is this? Negative 2.14 times 10 raised to 4. 2.14 times 10 raised to 4. We are not done yet. We have to check whether kinetic energy conserved. Okay, so now we're going to check whether the kinetic energy conserved. I think we're going to check this way. All right, so yeah, it's not a big deal. So half mv squared, so mp vp squared plus half mh vh squared is equal to half mp vp prime squared plus half mh vh prime squared. Now remember the velocity, bring those velocity over here. So I'm gonna copy paste this to velocity because because they are important. So helium is the positive one. Alright, so this is the helium one. So this is velocity of helium, this is velocity of proton. Okay, good. So now this one is 0 because of course it was at rest. Half cancel. Alright, so MP is 0.1 of course, and VP is of course 3.6 times 10 raised to 4 square is equal to MP. MP is how much? MP is 1.01. VP prime is square. So VP prime is square is negative 2.14 times 10 raised to 4 square plus MH 4 times VH prime 1.45 times 10 raised to 4 square. Now you will see that this one is equal to this one. Okay, that would be cool if you see it. All right, so 3.6 square times 1.01, so it's gonna be my calculator is not good. It's a broken calculator. Jeez. So 3.6 square times 1.01. Alright, so 13 times 10 raised to 8 is equal to, alright, let's see, 2.14 square times 1.01 is 4.6 times 10 raised to 8 plus 1.45 square times 4 is equal to 8.41 times 10 raised to 8. Okay, now 13 or we can 1.3 times 10 raised to 9 is equal to let me see, 4.6 plus 8.4 is equal to oh my, 1.3 times 10 raised to 9, 1.3 times 10 raised to 9. This is the time when physics student eyes filled with tears.
Brought to you by Brilliant.org.
Bari Science Lab to fall in love with math and science.